Find the order and degree of the given differential equations. Also state whether they are linear or non-linear. Problem number 1. So here we have third derivative of y with respect to t plus the second derivative of y with respect to t plus the first derivative of y with respect to t whole squared will be equals to e raised to the power of t. Here, the highest order differential coefficient is the third derivative of y with respect to t, so its order is going to be 3. And if we look at the power of the highest order differential coefficient, that is 1, so its degree is going to be 1. Now, talking about the linearity, it's going to be a non-linear differential equation, because if we look at the third term, so we have a squared term there, which makes it a non-linear differential equation. Number 2. So here we are given the second derivative of y with respect to x plus 4y is equals to 0. When we look at this equation, the highest order differential coefficient is d squared y over dx squared, so the order is going to be 2, and if you look at its power, it's 1, so its degree is going to be 1. And the linearity, it's going to be a linear differential equation because it is expressed in a polynomial form. Problem number 3. So there is a typo here. We have the first derivative of y with respect to x, it's not t, whole squared, added to 1 over the derivative of y with respect to x, and that is equals to 2. Now what we'll have to do is we're going to simplify this particular differential equation. We're going to multiply throughout it dy over dx, so that is going to give us dy over dx whole cubed plus 1 is equals to 2 times dy over dx. Now if we look at this particular simplified differential equation, we see that the highest differential coefficient is dy over dx, so that means the order is going to be equals to 1. If we look at the power of the highest differential, we see that it's 3, so the degree is going to be equals to 3. About the linearity, this is going to be a non-linear differential equations because we have a cubic term. The first term is cubic in nature, so it's going to be non-linear. Moving on to the fourth problem, so we have square root of 1 plus the derivative of y with respect to x squared equals to c times the second derivative of y with respect to x whole raised to the power of 1/3. So we have radicals on both sides, so we need to get rid of it. So we begin by first squaring both sides, so that is going to give us 1 plus derivative of y with respect to x squared is equals to c times second derivative of y with respect to x whole raised to the power of 2/3. Then we need to get rid of the 1/3 on the right hand side. For that we are going to cube both sides, so that will give us 1 plus derivative of y with respect to x squared whole raised to the power of 3 is equals to c times d squared y over dx squared whole squared. Now when we look at this particular simplified form of differential equation, we see that the highest differential coefficient present here is d squared y over dx squared, which is the second derivative of y with respect to x, so the order is going to be equals to 2. Now coming to the degree, we'll have to look at the degree of the highest order derivative. So we look at the term on the right hand side, so we have a highest power of 2, so the degree is going to be equals to 2. And finally, coming to the linearity, it's going to be a non-linear differential equation because we have lots of cubic, lots of squared and cubic terms present, so that makes it a non-linear differential equation.